Hey guys, welcome back to my attempt to use a Hewlett-Packard 8444A tracking generator with a Hewlett-Packard 8568B spectrum analyzer in conjunction with this old TV to see if we can attempt an alignment. Now, previously, we had hooked the tracking generator up to an external 500 megahertz reference from my 8662A, and we observed the output of this device on a scope, and it sure looked like it was sweeping. I then connected the output of this to the spectrum analyzer, and we got a nice flat response. Since then, the active probe has shown up. Previously, I just took the 50 ohm impedance output to the 50 ohm impedance input of this, and that's all. We're just going right output to input. Now we're using this active probe. Why? Well, a couple reasons. The big one being to protect the spectrum analyzer, because it has AC coupling. So let me back up a little bit. This is a box. Alright, so what is this box sticking here? Well, I connected this directly into the BNC jack. It's a little box here. It has a cable coming out that goes over into this probe power. There is a FET transistor and a few components inside of this. Now, one thing this does is it gives you 10 mega ohms input impedance. Without it, this has 50 ohm input impedance, which is pretty low for a sensitive tube circuit. So with 10 mega ohms input impedance, that means that when I connect this probe to ground and attach it to a circuit, it's going to look as if a 10 mega ohm resistor was connected from that point to ground, which typically doesn't cause any problems. Also, it's low capacitance, 10 picofarad. If you were to put a large capacitor from a sensitive circuit to ground, that would also affect its operation. Okay, so we get that. It's a buffer, and the output of this box is 50 ohms. So high input impedance converts it to low input impedance, a buffer, if you will. It also has a switch for AC versus DC coupling. In the DC position, whatever comes in goes through the amplifier right into this. AC coupling puts a capacitor. It'd be like if you took a capacitor between this probe tip and the circuit you're sensing, probing around. It'll block any DC voltage from getting into the FET and into this, because we don't want to blow them out, because we could have a few hundred volts at any given point inside of this set. And the input I'm using has a warning, 0 volts DC max. Now this input says 50 volts DC max. However, it does not have a BNC input. It has one of these guys, I forget exactly what they're called. Now I do have an adapter to convert it to BNC. However, if you do that and plug this into it, it sticks out pretty far, and it only has this little dinky cable to power. It doesn't quite stretch all the way over. So I'm taking the risk of using the most sensitive input. We also have attenuation, divide by 10 or divide by 100, in case we have the signal we're looking at is going to be too strong to come into it. So is this probe working? Well, one way we can tell is we can disconnect it. So, no input. Now we've just got our noise floor, just sampling whatever is randomly in the environment. If I plug this back in, we've got our line. Now it's not perfectly flat, meaning the frequency response of something is not perfect. Now, could be my cables. I'm just, after all, my output cable is just a really cheap BNC going to alligator clips. Could be this device. Nothing's perfect, but that's pretty good. It's pretty flat. Alright, cool. And I'm going to 24 megahertz center frequency with a 10 megahertz span width. There's a reason why I did that. That's what the alignment instructions for this particular TV say to do. Sweep generator coupling, sweep generator frequency 24 megacycles, 10 megacycle sweep. Translating into this device, that means 24 megahertz center frequency with a 10 megahertz span. Now, if all goes well, and we inject a signal into the set, and I probe around at various points, we should see something like this, but they will be inverted. For some reason, well, not for some reason, the devices they would have used back then would display the waveform frequency response like this. This modern stuff flips it around, which actually makes more sense, because what this means is we have peaks at these points. It looks like we have a signal drop off at these points, but actually it's the other way around. It's a flat response, and then it peaks up around here, and then it trails off. Okay, so what do we do to make this work with this TV? Well, one, we're supposed to inject the signal high side to pin 1 grid of 6AH6, low side to chassis. Now you move that around depending on what point you're at. And for the later stages, you're supposed to take a tube shield over the mixer tube, the converter tube, and the low side to chassis, meaning the tube shield will couple the signal into the tube underneath it. But let's start out with one of these steps. Dummy antenna, 500 microfarad. What does that mean? That means you don't just take this output and clip it right to the grid of that tube. You take a 500 picofarad cap between the end of this and pin 1 on that tube. Alright, we can do that. And then it says connect the scope through a 100K resistor to test jack S, low side to chassis. What does all that mean? Well, we're not using a scope, we're using a spectrum analyzer. So we connect our spectrum analyzer probe through a 100K resistor to test jack S. Test jack S is right here. It's a pin jack. I don't have any pin connectors handy. I think I've got some somewhere around here. It's a really old-fashioned type of connector, sort of like a mini banana jack. I'm just going to clip it to the other side, and then I'll put a 100K resistor between this and my spectrum analyzer and see what we get. Well, I admit it's not the greatest setup because I'm going to stretch my leads kind of long, but here's my blocking cap going to the injection point way down over here, and I've got my spectrum analyzer probe going to that test point, and rather dubious ground leads connected up, but we do have something, and I can prove that's a result of this guy because I can turn the level down. It drops off. Doesn't look that great though, and then something occurred to me. The point where we're probing here is after the detector. This is meant to have RF going into it, and it has its own detector built in. I'm using AC coupling, but boy, this is a DC voltage level at this point. Now, I don't want to switch this to DC mode because this has 0 DC input. But let's try using this guy and put this into DC mode and see if we can get that working. Another option is to not put this after the detector, but put it at the input of the detector where we do have the IF frequency of 20-something megahertz. Actually, let's try doing that first because that's the easier thing to do. So forget about using this test jack S and all that, which would be great if we were doing it the other way, which we can experiment with doing as well, which is to use a sweep generator going into this and use a scope and XY mode with DC coupling to look at the output of that test jack. So that's the thing with using this setup. Yes, you can get beautiful results and all that, but you're not going to be following the directions exactly as they're spelled out because we're not using an oscilloscope. We're using a spectrum analyzer. Not quite the same thing. Alright, so first off, where is jack S going? What are we probing right now? Well, here it is. Test jack S. If you go around and around and around and over, it's going to pin 2, the grid on the first AGC amp. If we go backwards a little bit, that's going to the output of the video detector and first video amp. Yeah, they take a 12AT7 dual triode, connect the grid and the plate together on one side, and that is the detector diode. And there's a signal coming into it. So I propose we check out pin 3, which is the input to the detector, with our spectrum analyzer and see what we can see at that point. And I'm injecting the signal right now at pin 1, the grid, and the AH6 video IF. I think it'll get more interesting as we inject further back down the line and we go through more of these IF circuits. Alright, going to the input of the detector now, and it definitely looks different. However, now I think we might be running into another issue. See, there's another device I'm waiting for to arrive. It probably won't get here for 3 or 4 days, and that is an attenuator. This puts out a pretty strong signal. Way too strong as we start working our way back. Right now we're just going through one stage, but once we go back to this through 2 stages, 3 stages, this is going to be putting out a much stronger signal than we want. I've ordered up an attenuator. See, this variable control goes from, I think, 10 dB to 0 dB out, or 0 dB out to minus 10 dB. Either way, that's a really strong signal for this kind of circuitry. So yes, we do see a trace here, and there is a bump here. I think I'm putting in too strong a signal. So there's a couple ways we can attenuate it. One, I could rig up a couple resistors to make a voltage divider, but I believe I could also use a smaller capacitor to accomplish a similar thing, although it's going to have some effect on the frequency. Really the right way to do it is to get a proper attenuator. Been playing around with different attenuator setups, and we're at a good point now here where I could give you some idea how sensitive this stuff is. So right now I have the RF generator going to nothing except in this little terminator I'm throwing together here. But we're seeing a waveform on the spectrum analyzer. It's just going through the air from here into the receiver, and we're picking it up. And this is a lot more like what we should be seeing with the double humps and all that, superimposed with a whole lot of noise. Now, if I go ahead and directly hook this up to the set again, I think we're going to see things being off. So you put too strong a signal into something, and it really throws off the response curve. Just ground it a bit. So I think that is a little bit misleading. I think I really need to get that attenuator and dress my leads better. But this does look promising. So what did I rig up here? Well, something else I was glossing over is the output of the RF generator is a 50 ohm output impedance. It should really be terminated at the end with 50 ohms. So I took a 47 ohm resistor and a 3.3 ohm resistor, pretty close to 50 ohms, and it's just going directly across the output. I then took that tap on the low side, so the 3.3 ohm side, and then going to my coupling cap and going into the set. So that's not only terminating the output of the RF generator, but it's also attenuating it. But even so, we need to attenuate it even more than that. And again, if I, it's back at the display, if I disconnect this, we still get a response curve. It's not connected now, it's just going through the air, and it's picking it up. So we need to use shielded cables, and depending on where I put this, it's wildly changing. We need shielded cables, we need shorter lead lengths, we need proper termination, we need proper attenuation. Is it all worth it in the end? Well, we shall see. Of course you don't need all of this to align something. Of course it's gross overkill, and it's not even designed to do what I'm trying to do. So why am I trying to do it? One, I bought this partly out of curiosity. People have been asking me to delve into the spectrum analyzer test equipment realm for a while. I got a tiny SA a few years ago, played around with that a little bit. And I like test equipment from this era. It pairs up nicely with my 8662. When I use this every day to do alignments, I try and get everything set up perfectly. Because I've seen photos of other guys who have everything set up right. And it's a gorgeous display. Much better than I've seen with a more conventional alignment setup. And having things like being able to have that marker dot you can move around, and there's things like video bandwidth, resolution bandwidth. Like, see this noise down here? We can put a filter on that. And we can get rid of that noise. Things like that you can't do on a normal device. Here's what I was just playing with. So right now I have a 3 kilohertz video bandwidth. If I go even lower, it gets rid of the noise. It filters the noise out. And if you want to see more detail, go for it, but then you see all the noise. And resolution bandwidth you play around with a bit too, and it has a drastic effect on, or it can have a drastic effect on what the output looks like. Being swamped by noise. So I need to get all this stuff right to accomplish what I want, but once I do and get everything dialed in, it should look great and give fantastic results. We're just not quite there yet. But it does appear that this equipment is doing what it's supposed to be doing. I was just chatting online with a colleague, and he confirmed what I surmised, that yes, the input to the spectrum analyzer has to come before the detector. He also warned me, don't expect to be able to do a full alignment check where you put a signal into the antenna and check the output, because it gets down converted. So for example, let's say you put 50 megahertz into the antenna input and the tuner outputs 25 megahertz. Well, if you inject 50 megahertz with the tracking generator, the spectrum analyzer is going to be looking for 50 megahertz, not 25, and it's not going to see it. So to use this to align a tuner or to do a full alignment check going from the antenna all the way to the video output is not really possible. But nonetheless, we're still going to pursue this, because to do IFs, which is what typically most of what you do. I don't typically need to align a tuner. It's a bit tricky to do even under the best of circumstances. The main thing I want to do is align IFs, and we can absolutely do that if we get everything set up right. Okay, for now, while I wait for the attenuator to arrive, we're going to play around and check it out using the more conventional setup. Scope, XY mode. In this case, it's fully counterclockwise with the sweep control. The X input, the channel 1 input is your X. So let's hook that up. Okay, and it's for the sweep generator. We're using an 8662. I already set it up, same deal as with the spectrum analyzer. Center frequency 24 megahertz with a delta of 10 megahertz. Now on this, I do have a very nice attenuator, and I have a lot more control, so we can get this much lower. We're going to take the RF output of this and hook it up exactly the same way. I don't want to alter anything. But now the difference is we are going to hook up the scope to the scope output rather than having to monkey around, poking around inside before the detector. So let us see where we should go for that. Or rather, let's get that set up. I'll use the scope probe here, channel 2. Just need to get the other end of it. Alrighty, things untangled, man. Probes do have a way of getting twisted up, don't they? Now here's a few pointers for you guys. If any of you out there have this type of scope or sweep generator, Okay, it took me a while to figure this out when I first put the scope in XY mode. So it was normal sweep mode, fully counterclockwise until we were in XY mode. You know that because it's channel 1X down there. Okay, hooked up channel X to the sweep output. I have a diagonal line. What the heck is going on? I have no input. I would expect to see a flat line. And furthermore, I do have channel 2 hooked up, which should be Y, and it's not deflecting at all. Okay, a couple things. You need to turn channel 1 off. Seems counterintuitive, but right now, with only channel 1 on and no other channel enabled, channel 1 is feeding both the horizontal and the vertical, so we get a 45-degree line. You turn channel 1 off, and we have to turn channel 2 on. Now we're set up. And to get it to go full screen width, you need to manipulate the position, which is annoying because the position lines go, it says vertical position with arrows going up and down, but it actually moves it left and right when you're in XY mode. And you alter the volts per division to make the line go full width. Just brighten this up a bit. Something else I'd mentioned in an earlier video. By using a sweep generator like this, it's digital, it is not analog. And there is step sizes, so now right now I'm in 100 steps, which means when it's going from the low frequency to the high, it's not continuous, it's not smooth, it's jumping. Ding, 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 ding. And if you look close, you see spikes on that. Expand this out. See all those little dots there? That's why this isn't the greatest setup. I mean, this thing is fantastic. It's got 5 programmable markers, a huge frequency range, incredibly stable and accurate. But when you're sweeping, it is digital and it jumps. You can do 1,000 steps, but notice what happened. The sweep rate got cut by 10. Now it sweeps really slowly, which when you're aligning is really annoying. So we'll try it out a little bit, but that's the fastest. I can only go slower. So this is the finest, the smallest steps when incrementing in frequency and the fastest sweep rate. That's as good as it gets. So I typically do it like this and just live with the decrease in sensitivity, or I mean accuracy, I guess you could say. Okay. I don't actually have the input hooked up to anything just yet. Or no, I do. Never mind. But we're not seeing anything, right? I think it's because I have my RF output at minus 39 dB, and I still have that attenuator I threw together for the other device, so it's really cutting the signal down too much. So let's increase that. Alright, let's increase that amplitude. So we're minus 40 dB, minus 30 dB, minus 20 dB, minus 15. Now we're starting to see something. Alright. But notice it's upside down compared to the other device. However, that's how they show in the server's info. So if you hook up the equipment like they show and use that output, negative going down means an increase in amplitude. That's actually not too different from what they show. But it's also not quite what we were seeing on the spectrum analyzer, is it? Now I know that this setup, this configuration works. Shortcomings and all about the discrete steps and the frequency. I trust this setup better because I've done this before. So the goal is to get something that looks close to that. Yeah, this stuff is very sensitive. Everything matters. Shielding, lead length, where you stand, where you put your hand. This is where people start pulling their hair out. But anyways, the goal is to get something on a spectrum analyzer that looks like that, but better. But better. And like I said, this has programmable markers, so We're supposed to have a peak at 21.6 and 25.9. And by the way, I can invert this. I do believe. There we go. So if that really bothers you and you want to think about upping a stronger signal, most scopes have an option to invert the trace. So there we go. Looks a little messy, doesn't it? Let's throw a couple markers in there. So 21.6 and 25.9. Very hard to do. It's going to have the chassis right in front of my RF generator, but I'll see what I can do. So I'll just turn on one marker and set to 21.1. Oh yeah, right. Forgot about that. There's something wrong with my scope's intensity modulation, so even if I program in some markers, we won't see them. We should see a bright dot where the markers are, but that doesn't work. The only thing that works is if I hold the marker button down, we get that. So I do have some programmed in, we just don't see them. So you know what, I'm not going to bother messing with the markers right now, since they don't work right anyways. I need to use a different scope, or the WaveTech XY monitor I was tinkering with a while ago. Alright, so last thing I'll do, boy, I do not have something grounded or shielded very well. Well, pretty much everything. These test leads are terrible, so I'm just using alligator clips with the aren't coax. So let me talk a little bit about what I should be doing. Alright, so the output of most devices is going to be 50 ohms. And what it expects to see is a cable coming out of it that is a 50 ohm impedance coax, and you want to ideally have it shielded all the way to the very end. Now you do need to connect it up into your device eventually. So rather than having 8-inch long bare leads with alligator clips, it'd be much better to have the alligator clips coming out as close as possible to the end of the coax. And you should have a 50 ohm terminator right there, ideally non-inductive, 50 ohms right across, somewhere very close to where you separate the ground and the internal shielded lead. And then the 2 alligator clips and clip it as close as physically possible to the device. Do not do this. Alligator clips unshielded to some components going to more unlong shielded wires. That's why everything, if I just move my hands around, wave them around, things are changing. This is a terrible setup. That's why scope probes are like this, where they have the ground clip just coming right out of the body. Even this is a bit long compared to some higher frequency ones. The clip would be like right here. And that's why that you can do this too if you really want to get in there. You want all this stuff to be as short as possible, as close as possible, keep everything shielded. I'm going to try hooking this directly up to this port and get rid of this lead with the 100K resistor, because I really don't think we need it. Let's see if that improves things at all. Alright, so yeah, it looks about the same. I figured we didn't need that resistor, an extra lead, just adding to the mess. Now it's still pretty bad. And that's because I'm just putting my hands down near this stuff, and just doing that is affecting things. So it's also much nicer to do this with the chassis down. Because the chassis itself is shielded. It's a big grounded box. So ideally, flip this down, inject all your signals from the top, make all your adjustments from the top. And they really went to lengths to make that possible with this setup. All the coils are accessible from the top, and there are injection points on the top. And then they put those outputs down here for the AGC in your scope. So ideally, there's no reason to have this thing on its side. It should be down. And when it's down, this whole metal thing is between you and the sensitive circuits, and it wouldn't be getting affected by me moving my hands around. So I have to do that to grab an alignment tool and start tweaking things, as I have to kind of manipulate things. Just putting my hand on the chassis is changing it. Anyways, let's grab a tool and tweak things a little bit, and you'll see with this, just like with the other setup, when I tweak a coil, I need a little more light, can't see what I'm doing. But when I tweak one of those slugs, the response curve changes. Yeah, so it's going up now, it's peaking up on the right. Actually, that's looking a lot more like it's supposed to. It's supposed to have two peaks like that. But then when I take my hand away, the peaks are supposed to be equal height. Took my hand away, now the left one shot way up. So it's not, yeah, you have to get all this stuff right. So this is where when people talk about alignments being difficult, okay, it's one thing to understand how the equipment works and how to hook it up. But that, once you get the hang of it, it's pretty straightforward. You inject a signal at this point, you read out the signal at that point, you configure stuff on your test equipment. That's one thing. It's this stuff where the kind of the magic or the experience comes into play of knowing about lead dress and ground effect and where you can put your hand, and that you need to use plastic tools and all that fun stuff. Okay, I think that's enough for now. We'll get more into this when the attenuator arrives. I think I'm going to have to make up some custom cables. I'll grab some 50 ohm coax, maybe sacrifice a BNC cable, because I have a bunch that have a BNC at both ends, and cut one end off and rig up a couple little alligator clips with a terminator to make all this a lot more stable. Because with either one of these setups right now, I can't do an alignment like this. It's way too sensitive as I'm moving things around. It needs, the display needs to not change as I'm moving around and grabbing different tools and such. Otherwise, it's going to be garbage. All right, that's it for now. Thanks for watching.